Good morning. So once again, Neutron Decay Cosmology, because until until this is understood by somebody, at least, 'cause I don't think it really is. So we have hydrogen. This is the beginning of the universe. Let's not go too much earlier. We'll get to that in a minute, but you start off with some hydrogen. The hydrogen coalesces because of gravity and other binding forces and becomes stars, etc., etc. Gathers through fusion. It becomes all the elements, planets, etc., etc. All the more heavier elements, but these all originated from hydrogen. They fused into the other elements. Eventually, we're just following sort of like an evolution path here. Hydrogen fuses with a bunch of elements and stars and stuff. Okay, I know it's sounding very vague, but there's a lot of different paths. Sometimes you end up in a supernova and you might be a piece of hydrogen that gets expelled in the explosion. Or you might be part of the hydrogen that fuses together to become like a white dwarf or a neutron star or something. There's lots of paths. Eventually, though, because gravity, all paths, every atom, maybe there's one that never made it, but every atom will eventually become heavier and heavier until it goes towards being a neutron star. A neutron star takes all of these elements and, through electron recapture, turns everything that was a proton and electron back into a neutron. So everything is neutrons at neutron star. There's probably maybe a proton here or there that expels on the surface membrane, etc. Otherwise you wouldn't get any scintillations happening. Okay, but basically it's neutrons. All neutrons. But they're still individual neutrons, just jostling up against each other. Then, catastrophic event happens. You get enough of those neutrons jostling against each other in the right conditions. They bind into one large neutron, which is the event horizon. Every event horizon should be thought of, in my opinion, as one gigantic singular neutron. And this is how we save information paradox. So now we have an event horizon, a giant neutron. It's the heaviest thing there is. It's like a perfect membrane of mass. Neutrons, when they contact the event horizon, once it's gone, because it's singular, they're bringing in information. We need to pass that information through. Those neutrons pass through space-time because at the event horizon, remember, space and time don't really mean anything because they've been so compressed that everywhere, anywhere is everywhere at the same time at the event horizon. So you fall through the event horizon as a neutron. You reemerge because we lost a neutron here. The universe is now missing complexity. It comes back right here. The neutron emerges from the lowest energy density point of the universe because that's the place where the quantum basement is the easiest to penetrate. Individual neutrons bubble up here and there in space. They're just going to pop out of existence, and that's going to be hard to prove, but it's the only thing that makes sense in terms of a process as a natural scientist. So these neutrons emerge in deep voids. There's a neutron. What happens to a neutron after 14 minutes? It decays. Decays into a proton, electron, and an antineutrino. A proton and electron is hydrogen. There's a temporary part in here where this is going to be amorphous proton-electron soup. This is dark matter. The neutron decays into dark matter. In time, it stabilizes and becomes hydrogen. But even atomic hydrogen is extremely difficult to spot. This proton-electron soup will be impossible to spot except for gravitationally. The charges balance out. The proton has mass, so it will interact that way. It seems it has a lot of mass. And from my understanding recently, the mass of dark matter was estimated, and it came someplace between an electron and a proton. So let's just call it, split the difference, and we'll call it monatomic hydrogen. Amorphous monatomic hydrogen becomes actual monatomic hydrogen, and at this point, now that it has a stable orbital electron, and I'm going to draw it this way, even though it's totally not the way it really is, but it's a cute diagram. Anyways, now that it has a stable orbital electron, now it can scintillate, now it can absorb, even though monatomic hydrogen is actually very difficult to see. But then it binds together and becomes duatomic hydrogen, follows this path, fusion of elements, boop, boop. This is the cycle of the universe. This is a world line. You emerge from the deep void, you decay, you become hydrogen, you fuse, you become neutronium, you fall through. This is neutron decay cosmology. You can bring up a whole bunch of complexities if you want. You can draw a circle using a point and a length of string. Or you can try and calculate all the infinite points, which you will never actually be able to do, and you'll always be guesstimating and estimating and making cheats to actually calculate using an equation, because there are infinite points. So we're just going to treat it as a continuity. Okay, there we go. And even from a Big Bang perspective, this is going to get a little longer than I wanted. But from a Big Bang perspective, look at this. Neutrons decay. So neutron could be seen of as that, like pre-Big Bang, the most dense form of anything. Then it turns into this, and there's darkness because it's amorphous and it can't scintillate yet. So this is like soup, quantum soup stuff, or maybe even this is. Then, finally, you have the electron capture, electron orbitals. Now you can scintillate. Now you have first light, which we haven't seen because it didn't happen in one single thing. It's a continuous event. There's constantly first lights happening all over the universe, and there always has been. The hydrogen fuses into elements through, stellar processes, etc., until it becomes denser and denser. Neutron star at the event horizon. This is where the snake eats its tail. Basically, neutrons fall through space-time, re-emerge in the void, and just follow this cycle eternally. Okay, I have other videos regarding why the Hubble Doppler exists, and that's because of parabolas are infinite. So there's an infinite universe, and we're on part of the parabola because we're in the middle, we're the bottom of the parabola, and we can only see so far on the parabola. And then things get so warped, everything gets so pulled that, once it's below 1 hertz or something like that, it gets pretty darn difficult to read. But still, there's an infinite range of frequencies between 1 and 0. Neutron Decay Cosmology. The expansion, I didn't even address this. The expansion from neutron to hydrogen is an expansion on the order of 10 to the 45. It is exactly, because one neutron fell in and one neutron fell out, critical density maintenance is built in topologically. It's to the universe. Neutron in, neutron out. You're never losing anything. It's a steady state through this mechanism. The compression that 1 cubic meter, because that's apparently how big a hydrogen atom probably is in the deepest space. So it starts off as being 1 cubic meter. Through gravity, it gets compressed until it's infinitesimal practically, passes through, expands. This is dark energy. There's an expansion of 10 to the 45. A neutron to amorphous gas is an expansion in volume of 10 to the 45. This is exactly the compensation needed for this. There's no actual expansion. It's all perfectly balanced. Neutron in, neutron out, neutron in, neutron out, information in. You're losing information, you gain the information. It's kind of messy and it's no use because it's like someplace else, but still, it's all there. This is a perfect closed space. A perfect closed process for the universe. It's a path of least action. You are just falling the entire time. You fall in, through, out, fall down. From here, you're still falling down. You just fall. Everything is falling all the time. Neutron Decay Cosmology. Can we get on board? Seriously, look at the logic. Show this to somebody. Show me where it's wrong.